So I want to review something here. So what is this big sigma symbol? So for instance, what if I had from k equals 1 to 10, 3 to the k? Well, this would be 3 to the 1, 3 squared, plus 3 cubed, plus 3 to the 4th, plus 3 to the 5th, plus 3 to the 6th, plus 3 to the 7th, plus 3 to the 8th, plus 3 to the 9th, plus 3 to the 10th. This will be my final answer. So the summation just means take whatever your variable is and you run it from the lower bound to the upper bound in terms of integers. That's what this would look like. The reason this is interesting to us is if we have a sequence, what if we have a sum with an infinity symbol? That's pretty wild, at least for us. So what if we had something like the sum from k equals 1 to infinity, 1 over 2 to the k. When you have a sum with an infinity symbol, this is called an infinite sum or an infinite series. And what we do to determine if this makes any sense is we define a sequence of partial sums. So these partial sums will be, let's define a sub k to be the sum from, I'm sorry, let's define a sub n because we need a different letter, to be the sum from k equals 1 to n of 1 over 2 to the k. So this is a sequence because if I plug in a number, for instance, a sub 1, would just be the sum from 1 to 1, 1 over 2 to the k, which would be 1 over 2 to the 1, which would be 1 half. And if I look at a sub 2, this would be the sum from k equals 1. This would be 1 over 2 to the 1 plus 1 over 2 squared, which would be 3/4. And if you look at a sub 3, you get that this is the sum from k equals 1 to 3 of 1 over 2 to the k, which is 1 over 2 to the 1 plus 1 over 2 squared plus 1 over 2/3, which is 1 half plus 1/4 plus 1/8, which is 7. And actually what's happening here is every time I get another piece of the sum, I start out filling out 1 half and then I fill in 1/4. And every time I'm doing this, I'm filling in half of what's left. What you'll see is as I fill in half of what's left each time, that the limit as n approaches infinity of this sequence is equal. The limit as n approaches infinity of a sub n is equal to 1. And when I write this summation, sum from k equals 1 to infinity, what I really mean here is that this is the limit as n approaches infinity, sum from k equals 1 to n, 1 over 2. So this would be equal to 1. Even though there's infinitely many terms, it only just adds up. Even though there are infinitely many terms, it only just adds up to the area of this square. So at the end of this, after all this discussion, I would write from k equals 1 to infinity, 1 over 2 to the k is equal to 1. So this means if you have a summation from k equals 1 or k equals 0, either way, to infinity of a sub k, what it means is the limit as n approaches infinity of the sum from k equals 1 to n a sub k, if this limit exists. So this is where we might need some intuition from our sequences, because this is actually a limit of a sequence of partial sums.